Okay. Okay, so guys, today we are starting 9-4, which is compound probability, which is when you have independent and dependent events. And we'll talk about each one of those. Okay, so as a warm-up, let's review what we've learned how to do with probability so far. So we have a marathon has 3 scattered starting times, each called a wave. Each wave then has 5 starting areas called corrals. So we have a wave and we have corrals that runners are grouped into. Draw a tree diagram that shows the possible waves and corrals a runner could be assigned to. All right. So we have the waves. So that's going to be the first division section that we have. So we have A, B, C. And then we have the corrals for each one. So we have 3, 4. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how many different wave and corral assignments are there? So that means what's the total? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's my total. If waves and corrals are randomly assigned, find the probability for wave B and corral 5. So B, 5. That's this scenario right here. So that's the only one. So it is 1 out of 15. What we're doing today is learning how to get this answer without having to draw the tree diagram. All right. So compound events. That is the probability of 2 or more simple events. Compound events is the probability of 2 or more simple events. Now, the first one we're going to talk about is independent events. Independent does not affect the outcome. It does not affect the outcome. Okay, that means the 2 things are not going to be related to one another, or they're not going to depend. The way you calculate your answer is the probability of 2 independent events is found by multiplying the first event by the second event. So for instance, excuse me, if I'm looking at number 1, what is the probability of rolling a standard dice twice and getting an even number, then a 5? So we would have the probability when we're writing our notation, we would say the probability of even, then 5. The key word here is then. That lets me know I multiply. So to do this, I do the probability of even times the probability of 5. So I've got a dice. That means that's going to be the numbers 1 through 6. So for it to be even, that's going to be 3/6 times how many 5s? 1 out of 6. Now, remember, we always simplify. So 3/6 can simplify to 1/2, which then gives me my answer of 1/12. We're just going to be writing our probabilities as fractions, not having to worry about all 3 different forms. You just need to make sure you understand that it can be represented in all 3 forms. All right, looking at number, we're going to jump down now and we're going to look at 3D. For number 3, we're looking at these 2 spinners over here. So it says if each spinner to the left is spun once, find each probability. So we have the probability of even and shaded, then the probability of not red. So I'm going to have the probability of even and shaded times the probability of not red. All right, so I'm looking over here. Even and not shaded. Two shaded. Oh, here's one. Here's one. Here's one. So I've got 3 out of 12. No, sorry. Oh, even and shaded. Oh, I'm flicking backwards. It's got to be even and shaded. Even, I'm putting the not in there. So scratch that. It's got to be even and shaded. It has to meet both of those criteria. So the 4 does not, but the 2 does because it's even and shaded. So that one works. 8 works, but 4 does not. 6 does not because it's not shaded, and 10 does not, and 11 does not. So this is 2 out of 12 times now not red. So that, well, that's going to be everything but red. So that's 1, 2, 3, 4. Oh, there's 2 reds. Pay attention. Red here, red here. So that's 3 out of 5. And we remember we simplify if we can. So this is going to become 1/6. And then we multiply straight across. We follow our fraction rules. So this is going to give me 3/30. But if I notice, it still ain't simplified all the way. I can divide by 3. So this is going to become, I'm going to divide by 3. So this is going to become 1/10. That's my final answer. Let's look at number 4. Okay, there's all kinds of different ways because now we're going to talk about a deck of cards. So remember, there's a total of 52. So we're going to look at the specifications here. So we've got the probability of a spade times the probability for the multiple of 4. Multiples of 4, that means 4, 6, 12. So if I'm not sure, so that's going to be 4, not 6, 4, 8. Wait a minute. I'm going up to, so 4 and 8 are the only ones because it goes 4 to 10, but there's 4 of each of those. So then I'm going to be doing like 2 times 4, which is, oh no, Kimberly, you're not paying attention. Month of June. I was thinking of it as a deck of cards. This is where, again, I say that math test is nothing but a disguised reading test. So I've got the numbers all the way up to 30. So I have 4, 12, 16, 20, 24, and 28. So that's 1, 2, 3, 4, 5, 6, 7. Okay, so this is going to be 7 out of 30 for the multiples of 4, and then spades, there's 13 spades, so that's 13 out of 52, and I'm multiplying those two. All right, now remember, we simplify if we can simplify. If I know that there's 4 different suits in a deck of cards, that means that 13 is going to go into 52 4 times. So this can simplify to 1/4. And now we multiply straight across, and I end up with 7 over 120. If you can simplify before you multiply, it makes you have smaller numbers. It makes this an easier problem. All right, next page. And this is all independent because they are completely separate from one another. One does not depend on the other. Okay. Looking at number 5. D. We want a parallelogram, which means that's where the parallel sides are. So here we're doing the parallelogram times the prime number on a standard dice. So prime numbers, that's going to be 2, 3, 5. Yeah, because 1 is not prime. It's one of those special case scenarios. Okay, so parallelogram. So we've got the rectangle, the square, the kite, and the parallelogram, or the rhombus and the parallelogram. So those are 4. So therefore, we've got 4 out of 12. There's 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute. 4 out of 8. 4 out of 8. I don't know where I saw that word number 12 from. Times, now I'm looking at out of a single die. So this is 3 out of 6. Remember, we want to simplify if we can simplify. And 4 over 8 becomes 1/2. 3 over 6 becomes 1/2, which gives me 1/4 as my probability. Okay. This is where it can be tricky. Okay. We've got to pay attention to the wording here because we're using the same stuff. There are 5 red marbles, 1 orange, 2 green, and 4 purple in a bag. A marble is drawn and replaced. When it is replaced, that makes it an independent probability event. It's an independent event, okay? Then another marble is drawn. We want to find each probability. So let's look at A. This means I'm doing the probability of orange times the probability of purple. So the probability for orange, well, first off, I got to figure out what's my total. How many total marbles are there? So I have 5 plus 1 plus 2 plus 4. So that gives me a total of 6. My total is 12. So how many orange? I have 1 out of 12 times how many purples? 4 out of 12. And then remember, we simplify. So divide by 4, and this is going to become 3. Excuse me. My brain's jumping ahead. 4 divided by 4 is 1. 12 divided by 4 is 3. So it becomes 1/3. And now we multiply straight across and we get 1 over 36. Now that's pretty straightforward. Where it can throw us sometimes, and we got to pay attention, is when it's both orange. That means I'm doing the probability of orange times the probability of orange. Well, we already figured out the probability of orange right up here. So I've got 1/12 times 1/12, which is 1 over 144. All right, now we get into the dependent events. When it's dependent, that means it affects, okay? It changes the outcome of the second event, okay? It affects the other event. You still calculate by multiplying, okay? So you find by multiplying the probability of the first event by the probability of the second event after the first event. So it's after, so you have to take that into consideration. So let's see, what does that look like? All right, so we're talking about another bag of markers, or this is a pencil box. So we have our 3 green markers, 6 yellow markers, 4 red, 12 blue. A marker is drawn and not replaced, okay? When it is not replaced, this means it is a dependent event because the second one depends on the first. Because once I take that pencil marker out, it's used. It does not go back in this scenario. So for this, okay, I'm doing the probability of red times the probability of blue after red. So I've got to figure it out after I pull out the red. Okay, so to begin with, I got to figure out, well, how many total marbles do I have of markers? So I have 3 plus 6 plus 4 plus 12. So that's going to give me 9 plus 16, which is 25 is my total. Okay, so how many reds are there? There are 4 reds out of 25 markers. But the thing to remember here, okay, is now, do I still have 25 markers? No, because we took one out. We only have 24 markers now because we took one red out. Took one red marker, not all four, only one red marker out. So total is now 24. But how many blue ones are there? We didn't mess with the blues, so there's still 12 blue. And simplify. I can simplify 12 over 24. That's 1/2. I just made my math a whole lot easier. 4 times 1 is 4. 25 times 2 is 50. And now I should be able to see, oh, that can be simplified as well. Divide by 2, which gives me 2 over 25. Let's do another one of these. Okay. All right. For it to be both blue, that means I'm doing the probability of blue times the probability of blue after blue. All right. So for blue, we figured that out. That's 12 over, but remember my total is 25. Now I've got to figure out, okay, I took out a blue. So do I still have 12 blue? No, I only have 11 blue. Do I have a total of 24? No, I'm sorry, a total of 25. No, I only have a total of 24 now. And now we need to multiply diagonally. Okay. Not diagonally, straight across, because I can't simplify. So when I multiply straight across, we end up with, excuse me, 132 divided by 600. If I look at this, 1 plus 3 is 4, 4 plus 2 is 6. So I can divide by 6. For starters. Oops, excuse me. So I have 132 divided by 6. And yes, you can use a calculator, guys. So that's going to give me 22 over 100. But if I notice, it's still even. I can simplify again. So I divide by 2, and that gives me 11 over 50 as my final probability. All right. One more with a little bit different scenario. So we still have a bag of something. We have 16 lottery, numbered 1 through 16. A ball is drawn, not replaced. Then another is drawn. Find each probability. Okay. So we have the probability of even times the probability of odd after. All right, so there's total of 16. The probability of even is going to be 8 because you've got the numbers 1 through 16. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's 8. But now when we have the probability of odd, my total amount of lottery balls is only 15. But how many are odd? 1, 3, 5, 7, 9, 11, 13, 15. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 there for the odd. Okay. So simplify what I can. This is going to simplify to 1/2. Now we multiply straight across. So I end up with 8 over 30. And I can see that can be simplified. Divide by 2, and we get 4 over 15 as my final probability. Okay, your assignment is to finish the notes in the classwork homework. And if you've got any questions, make sure that you rewind as well as come up and ask me. And the maze page is extra credit for your 5P grade. So the maze here is extra credit. But remember, you can't just draw that direction. You have to show your work. You have to show some work of how you're getting that answer in order to receive credit. Have a great day. Bye.